Okay, good afternoon. I am Miss Tsai. Okay, I will be delivering to you the lecture on binomial expansion. So, if you are in the Tuesday lecture group, you should be looking at this. For Thursday lecture group students, okay, please look at part 2 of the video. Okay, now the first part will be a revision from your secondary school work for binomial theorem for positive integral indices. So if you look at the formula, this is a plus b to the power of n, okay, and this is the formula. So I'm sure in your secondary school you have seen this before. The only difference is probably in the use of notation. Okay, instead of writing n choose 0, we write this bracket where we have n on top and 0 below. Okay, same for n choose 1. Okay, so this is just a change in notation. So just recap the few basic points. Okay, this expansion is a finite series with n plus 1 terms. Okay, and the sum of the powers of a and b is always n in each term. Okay, point number 3. Okay, as you can see in the formula, the powers of a decreases while the powers of b increases with each term. Okay, you can check out the formula. The powers of a will always decrease, whereas the power of b increases. Okay, and the general term, we call it the r plus 1 term. Okay, the notation we use is a capital letter T with subscript r plus 1. Okay, and this is how it looks like. Okay, n choose r, a to the power of n minus r, b to the power of r. Okay, it is also found in the formula. Okay, this is the general term. Now, if we let a to be equals to 1 and b to be equals to x, okay, we will get this. Okay, so the expansion will be 1 plus x to the power of n. We have 1 plus n choose 1x plus n choose 2x squared, and so on. So the general term here is n choose r x r. As you can see, the coefficient of the term in xr is n choose r. Okay, so similarly, the coefficient of x to the power of n minus r will be n minus r. Okay. Okay, since earlier we have already established the fact that n choose r is equals to n choose n minus r, therefore we can conclude that the coefficient of x to the power of r is equals to the coefficient of x to the power of n minus r. Okay, so let us look at an example. Example 1. Okay, obtain the expansion of x minus 1 over x to the power of 3. Okay, take a few, at this point you may want to pause the video to try out this example on your own using the formula that you have learnt before. Okay, if not, right, okay, using the formula that was on the previous, that was above, okay, you can do the expansion. Okay, again, the difference is that instead of using 3 choose 0, we use this bracket notation. Okay, so the first time you have x cubed and then x squared multiplied by minus 1 over x, followed by x multiplied by 1 over x squared, followed by minus 1 over x to the power of 3. Okay, so simplifying, you will get this. Okay, did you get the answer? Okay, now we go on to example 2. Okay. In the expansion of x plus 1 over x to the power of 4, find the coefficient of the term containing 1 over x squared and the term independent of x. So, for a question like this, we don't really need to expand the whole, we don't need to expand the term. What we can do is we can make use of the general term tr plus 1. Okay, so using the formula, I can write down what is the r plus 1 term. Okay, 4 choose r, x to the power of n minus r, and 1 over x to the power of r. Okay, you have just learnt indices, right? So from here, right, we can combine the powers of x, because this will be x to the power minus r. So we will get 4 choose r times x to the power of 4 minus 2r. So if we want the term containing x to the power of x, we want a term containing 1 over x squared. Okay, so the power of x in this case will be x to the power of minus 2. Okay, so what we can do is, I will equate the power of x here to minus 2. Okay, I will find that r is equals to 3. So if r is equals to 3, I can see that the coefficient of x to the power minus 2 will just be 4 choose 3, which is equals to 4. Okay, now using the same method, okay, you may want to try part B on your own. Okay, you can pause the video to try part B on your own. Okay, before you go on, a hint. Okay, for the term independent of x, okay, what should the power of x be? Okay, yes, the power of x should be equals to 0. Okay, because when x is to the power of 0, you get a constant 1, so there is no x in that term. Okay, so you may want to pause the video now and try it on your own. Okay, so for those who have tried, okay, same thing. Okay, using the general term, I equate the power to 0. I will have 4 minus 2r to be 0 and find that r is equals to 2. Therefore, okay, we go back to the general formula. When r equals to 2, we can see that the coefficient is simply 4 choose 2, okay, which is equals to 6. Okay, did you get the answer? I hope you did. Okay.